Right, a quick reminder to you just about the review session next Monday. So it's been confirmed. So it's going to be review for your written test, CLHM, not this classroom, but CLHM, 10 a.m. to 12 noon, next Monday, September 30th. Okay, just go there and ask questions. I posted a Google Doc over there. So as you're studying, feel free to post questions over there so I can prepare beforehand, but it's optional. Okay? And then notice that there will be a seating plan for your lab test. I'm going to announce exactly what the plan is over the next few days, so you'll be precise. But you're going to sit according to the plan. Okay? All right. Let's now go back to where we were. Okay? We're basically going to talk about this particular example over here. Okay? This counter. Okay? Let me just remind you very quickly what the issue is, and then we have to look through basically the first version of all the tests in console tester, and then move on to JUnit test. We want to do both and do some comparison today. Okay? Again, the counter, remind you very quickly, counter class, we got maximum, we got minimum, 0 to 3. Okay? And also constructor get a value, and there are two mutators over here, and we got to be careful when we try to increment or decrement. When you try to increment, you want to make sure if the current value already reaches the maximum, you want to throw the value too large exception. Symmetrically, if you try to do decrements, when the value already reaches the minimum value, you don't want to get to -1, so you throw the value too small exception. Okay, simple example. We're going to use this example over here and then see how we can test the different methods over here, specifically increment and decrements. Okay, let me just do a very quick reminder to you. The most important thing when you study for exceptions, one is about the catch. We'll specify, we emphasize it for many times. I'm going to leave that to you to study and ask me questions if needed. What we said last time, another most important part about exception is you have to distinguish between normal flow of execution when the exception does not occur versus the abnormal flow when the exception does occur, because the flow will be disrupted. Okay? Let's now see what I really mean. Let's see this particular line over here, O.n. Let's assume that n potentially may throw some exception, conceptually. It might throw. That requires us to either specify or catch. Let's say we choose the catch option. So we say, try this particular method here, and then we want to catch, right? So now, let's say the normal case. Let's say when we try to execute this particular line and the exception does not occur. In that case, we'll simply just go on to execute the rest of the try block. And after that, we'll simply go to the end of the, basically, after that, we'll skip the catch and then go for the rest of the code. Okay, that's kind of the flow. Let me highlight it. Okay, we're going to see this kind of flow over and over. Try this method here. If the exception does not occur, try the rest of the try block, and also skip the catch and then do the rest of the method. Okay, that's kind of the flow. That's this non-disrupted. On the other hand, if the exception does occur, in this case, let's say when we call O.n, some exception did occur. In that case, we're going to skip the rest of the try block, and then we go for catch, let's say, for that particular one, and then we're going to execute the entire catch block, and then after that, we're going to finish that and finish the rest of the code. Okay? So that's the two kinds of flows you have to be very clear about. Because when we are trying to do a test, sometimes you do not expect an exception to occur. On the other hand, sometimes you do expect the exception to occur. So you have to be clear about in which case should be considered as a success, in which case should be considered as a failure. Okay? But that's the principle over here. Any questions? That's actually from last time. I want to do a quick review. Okay? And after this, let's go back to the slides. So we're going to consider different kind of tests. So let's say you try to simply just initialize the counter object and do increments. So in the green one, we do not expect the exception to occur. On the other hand, for the red one, you initialize the counter object with value 0, you try to do decrements. So that should be abnormal. That means you do expect the exception to occur. So now, because of that, okay, one is you simply expect no exception should be occurring, and you expect the value to be incremented from 0 to 1. On the other hand, you expect the value too small exception to be thrown in the other case, right? That's something we want to test. Okay, we had a very quick view of the first test last time, but let's review it. Okay, we're going to see how we can play with the example. Okay, that's the slide we went over last time, and the test may either pass or fail. So let's now do the first version of all the tests. We're going to do console tester, which means every time you want to run the test, you have to right-click on the class with the main method and say run as Java application. If you have 5 different tests, you got to do this procedure 5 times. Okay, that's the first version. And then we want to see how we can move from that first version to JUnit version, which is completely automated. So we want to see exactly the comparison. Okay, so now what about the first test? Let me go right to the points for the first test. The first test, we had a quick look at that last time. Okay, let me just go over with you very quickly. And then we talk about execution flow. So now, if you look at that, it's a class with a main method. It's a console tester. We create a counter object over here, and then we simply say, what should be the current value? So in this case, we are testing c.getValue, and the value should be 0 initially, right? So we're going to see from the console if that's really 0. And then we're going to call c.decrements, and because that method throws value to small exception, that's why I'm going to wrap it around try and catch. And then, now, here comes the thing that can be tricky. Somehow I say over here, in the case where we can continue from this line into this line, in that case, we consider that as an error. On the other hand, if we simply jump from this line into the catch block, in that case, we consider that as a success. You can see the 2 different flows over here, right? That's kind of the thing you want to get used to. You want to know exactly what you want to test for, and then how you can put the error messages or success messages accordingly. Okay? Let's see what we are trying to do over here. Okay? Let's say this conceptually, and then I'm going to do some quick demo on what if the implementation, the code itself, is actually not correct. Okay? Let's talk about the normal case. Okay? The normal case, when we try to call decrements over here, okay, that's a normal case. I'm using green. The normal case would be if you try to call decrement at this point, when the counter value is simply 0. What we do expect to happen is the value too small exception to occur, right? That's a normal case. In that case, the flow should be disrupted, and we go right to this value too small exception. That's expected. So that's why we put success over here. Value too small exception thrown is expected. Okay? That's a green one. Any question? Okay? The next one over here, let's see. The next one, basically the same fragment of code. I'm just using that for comparison. Let's say we still reach over here, c.decrements over here, and then we have c.getValue. Again, what we expect to happen is the value too small exception should be thrown. But let's say there's something wrong with the implementation, something wrong. Somehow the decrement did not throw that exception, whereas it should be. What's going to happen is, since no exception has been thrown, we'll simply continue from this line here to this line. Okay? If we do that, that means error, value too small exception was not thrown as expected. Right? You can see we got 2 messages. One is about success, one is about error. In this particular case, one should be put immediately after the method call. The other one is put in the catch block for the reason I just explained. Any question? Here. Everybody clear about this? Okay? Yeah? You guys being very quiet, right? I assume you're okay. I'm concerned, right? That's why I'm asking. Right? Good. We're going to see many examples, so if you really get confused, please stop me. Okay, very good. So the expected behavior is when we call c.decrement, in this case, when the counter value is 0, we do expect this to happen, right? That's the first test case. Now, I want to show you an example over here. What do I really mean when I say, what if we are expecting the exception to be thrown, but it did not throw? That's the thing I want to explain to you, okay? So now let me go through a little bit slides over here, and then we'll talk about a little bit Eclipse. Okay, that's counter console tester 1. Okay, that's exactly what I just said. Okay, so you don't have to worry. You can just read through. And by the way, when you study the slides, eventually we'll talk about the equivalent but automated JUnit test at the end. So when you study the slide, you can feel free to click on the link. So it can link you to the corresponding slide, but we don't need to do it now. Okay, so now we already talked about the normal flow. Let me demonstrate that to you. Okay. So now what I meant by was, let me go to Eclipse. If I go to Eclipse and we simply go for under testing counter console tester. Now we talk about counter tester 1. Okay. For counter, for all the console tester, they're using this counter code. So this is what I call implementation. That's a code, right? You're trying to test. At the moment, pay attention to decrements. Okay. You can ignore the comments I have for you. Okay. So now, if you look at that, decrements method in counter class. At the moment, we are saying that if the value is reaching the minimum, we should throw that exception. At the moment, the implementation is correct. It is correct. Okay. So what I will do is I'll simply go to counter tester 1. Let's do the breakpoint very quickly to convince you. So what I will do is, first of all, I will go to put the breakpoint right beside line number 11, which means I'm going to pause the execution over there. Okay? And then I'm going to run the debugger over here. Okay? And I'm going to switch to debugger. Okay? So now you can see that the execution has been paused in line number 11. Okay? So now, and also so far the console output was initial value has been set to 0. Everything is okay so far. Now, what's going to happen if I say step over line number 11? What do I expect to see in this case? Since the implementation, the code is actually correct, in this case, we do expect the value too small exception to be thrown, so it will be thrown. Okay? So now, how can we verify that? If you look at the debugger over there, let me see, I'll find you the button you can click on. You can see over here, normally we simply just do, you can see the arrow over here called step over. There's another one called step into. That's also very useful. That means I'm trying to make this particular method called c.decrements at line number 11. Now I want to go into that method call and see how things are exactly being executed. Let's do that. Okay? If I simply say step into, what that would do is now we are stepping into the decrements over here, right? So now I'm now in the decrement method here, and then it's simply checking to see if this over here is counter, right? I can say this, if you expand the object, value is simply equal to 0. And remember, counter the minimum value is also 0. That means 0 equal to 0 tells me that I should throw this particular exception, right? So this is a correct implementation. It will throw. And then if I simply say step over here, and then step over. So now, you see what happened? Exception has been thrown, and then this line over here at line number 11 has been thrown, that particular exception. And line number 12, which is about the error message, was not printed because the flow was disrupted, right? So now we are simply going to the catch block over here, and then if you say step over again, it's going to say success. Value too small, exception has been thrown. So that's the successful case. Guys, any question up to now? Okay. Let me just, that's really important, so let me just repeat in a slightly different way. What I just said was like here, okay? First of all, notice that this particular coding over here is simply correct. I'm going to create an incorrect version a little bit later, okay? So now what happened was, when I reached that line over there, c.increment, I said step into. At this moment, c.value is simply just 0. So when I try to execute this block of code, value is 0, counter.minimum is always 0. So that means I'm going to throw this particular exception as expected. In that case, the flow over here will be disrupted, skip the rest of the try block, and go to this catch. And then execute the rest of the catch block, right? That's exactly what we said. So that's the disruptive flow case. But now in this case, because we did expect the exception to occur, so we're going to say success. The value too small exception you expected to occur, it did occur. Questions? Fine? Okay. What would be a different case? A different case would be, let me go through some slides with you. So far we have seen we are given some correct implementation, and then we'll simply create another console tester 1 that simply reaffirm that the implementation was correct. However, this is not the only value for test. I would say that's kind of the lucky case. Usually you're unlucky because you are still learning about programming. What will happen usually is when you are trying to run your test, the outcome may not be what you expect to see, in which case your implementation has to be fixed. Okay, let me show you exactly how this can happen. Okay, let me just go through a little bit concept on the slides with you, and then I'll do one more demo. Okay, it's really important to get this right. So later, all the later example, we follow the same logic. We're just trying to repeat so they can reinforce your understanding. Let me go back to the slides, and then, so now, the real value of a test, like a console tester 1, is not only to confirm when your implementation is correct, because it doesn't happen always, right? Even if you're a very good programmer, even if you're very experienced, you can still make mistake. But also, when your implementation is incorrect, the tester or test will actually signal some error to you. In this case, if the implementation was not correct, it should tell you in the console, error, the exception was not thrown, right? So now, let's see this. So what we want to do is as follows. Now pay attention to this alternative version of the decrements. You can see the only thing I changed was this. I say for decrement, it still might throw value too small exception. However, now I changed the condition. Rather than saying value equals counted at minimum value, I say the value strictly less than counted at minimum value. So what does that really mean? That means in this alternative implementation, I will only give you the exception if the current counter value is strictly less than the minimum value, not when it's equal. First of all, is this correct or not? It is not correct intuitively because, for example here, because minimum value is simply just 0. According to this implementation, when the current counter value is 0, you will still allow value minus minus. That will let you go down to -1, which is not allowed, right? That's already below the minimum value. Let's first agree this is a wrong implementation, first of all, right? It's wrong because when the counter value is minimum value, you are not really throwing the exception as expected. So now what's going to happen is this. We're going to run the same tester and see how the execution flow will be changed. Okay? Let's go back to Eclipse. I'll show you how you should reproduce what I'm doing now. Let's just go back to the example here. Nothing should be changed on the console tester 1. Nothing. Okay? All we do is go to counter test, counter class, and then also actually when you read the comments, I also gave you hints over here so you can follow them. What I will do is I'm going to modify this. At the moment, equals is correct. I'm going to modify so it becomes wrong. Rather than equals, I'll say less than. And make sure you save the file. Okay? Now, what we are facing is the same tester as before, but now the implementation has been changed to be wrong. Now we should expect a different flow of execution to occur. Otherwise, it's a bad tester. Okay? So now let's do the same thing again. Okay? So now let's go back to console tester over here, and then let's run the debugger again, which means we're going to stop at the same point and then step into it. So I'm going to run the debugger over here. Okay? So initial value is 0. Okay? So now I'm now at this point, right before I try to execute CETA decrements. And then I would say step into. Now you can see that the version of decrement we are executing is now in line number 62. It's strictly less than. Now, would this condition now evaluate to true or false? False, right? Because now you can see this the value, as we just saw, is 0. 0 less than the minimum, which is also 0, is false. So that means, look what's going to happen. If I say step over, now it's going to decrement the value to -1. That's bad. Bad implementation. A good tester should be that when your implementation is correct, it's going to reaffirm. When your implementation is wrong, it's going to warn you with some error. But let's see if there's a good tester. So now I'm simply just going to step over again, and we'll go back to the tester. Step over again, step over. So now you can see that we actually went from line number 11 to line number 12, right? That's a different flow. You see, we didn't jump. We didn't skip the rest of the catch block. So now we simply go to line number 12, and now that simply means no exception was thrown from line number 11. So that should be considered as an error. Okay, let me do a final summary of what I just said, and then I can take questions if you have. Again, this is wrong implementation. What we did was, what we are given, this is correct. However, I'm going to change that so that it's incorrect. I just use less than. Okay, and then I execute the same block of code for the tester. When I reach this line over here, C the value is still 0. So that means I'm considering 0 less than 0, right? False. So that means I'm going to decrement the value over here. So no exception has been thrown. That means I can simply go with a normal flow of execution from this line number 6 to line number 7. So that's why I will simply give you an error from the tester. So now if you consider the two cases, in the case of the correct implementation, it will tell me success. The exception you're expecting is thrown. On the other hand, in the second case, it will tell you error. The exception you were expecting was not thrown. Okay, two cases. Both cases are important because imagine that in the written test, if let's say, I'll just sketch the idea for you. I simply put this error message over here, this error message here, I put that into the catch. On the other hand, I put this success message and put it into after decrements. You have to justify to me why this tester is logically inappropriate. Okay? Think about that question there. Okay, any question about these two cases and this console tester? I'll take questions now. Okay, I can pause. Yes? You mean if I change that to be less than or equal to? Sure. So you're asking whether that should be correct or not, right? That's what you're asking. Okay, the question was, as I said over here, I said the way to create a wrong implementation is by changing equals to less than, right? Now, your question was, what if rather than changing that to less than, I change that to less than or equal to? Before I answer this question specifically, for you as a programmer, every time you play with your implementation, you want to know whether this is correct, how you can tell. Run the tester again, right? That's what you should do. And let's try that, and then I'll explain. It seems to me it's okay. It seems to me. Let's see this. If I go back to the counter tester and try your suggestion, would less than equal to be a correct implementation, right? Go back to the counter tester here and run it. It will tell me success. So that means it is okay, right? But now let's explain very quickly. The idea is very simple. When you're reaching this line again, so C the value is simply 0. So now what you're comparing is 0, the current value, less than or equal to the minimums, less than or equal to 0. That's true. So you will still throw the exception. Right? So I think, oh, guys didn't remind me. I did something over here. When you reach this particular line over here, right? When you reach this line here, you're trying to do C the decrements, but now we are trying this particular alternative implementation less than or equal to. C the value is simply 0, minimum is 0, so this would be true. So that means we'll still try to throw this exception. So that's why it's also correct. Okay. But the more important lesson is, every time when you're trying to change your implementation, not just for this exercise, but for any lab or future projects, anytime you change, you should always rerun all your tests. Okay? Let's do another one. Okay? Any questions before I go for another one? Okay? Another one is going to be a little bit more sophisticated, but we're trying to build up the complexity. Okay, so that's that's also about incorrect implementation. Okay, notice that the way I lay out the slides, when I try to trace the code on the iPad, I simply use arrows. But on the slide, you can see I also tell you exactly which lines are being executed in different cases. That's how you can also trace the code by yourself. Let's consider a different test. Basically, for this particular second test, still console tester, later on we're going to translate everything we said here for the console tester into JUnits, but the idea would be very similar. Okay? So now this is how we're going to set up the test. Before we were expecting the value too small exception to occur. Okay? Now we are trying to test whether increment method has been implemented correctly so that when the value reaches the maximum, you try to call increments, that should give you a value too large exception. Agree? Okay? However, this test is a little bit tricky. Thinking this way, in order to get to the maximum value, given that the initial value is 0, how many increments do we need? 3, right? We're going to say create a counter, increments, increments, increments. For those 3 increments, do we expect any exception to occur? For those 3 increments, we don't. However, it is only the 4th increment we try to do that should throw the exception. So now we got 2 categories of increments here. For the first 3, there should be no exception thrown. For the last one, there should be exception thrown. That's the little bit complexity we are adding here. Okay? But once you understand what I'm just saying here, roughly, you will see the code. Okay? Let me go over the code, and you'll go over some cases. First of all, we still do a try and catch. However, notice one thing here. In the console tester 1, remember after the decrement, we say it should be, oh, no, let me, I'll get there in a moment. Yeah, sorry. So let's say we try the 3 increments, see the increment, so 0 to 1, 1 to 2, 2 to 3, right? And then we try to check the value, make sure that's 3. And then I somehow have some nested try. You might be wondering why we are doing nested try. This shows you some power of the try and catch block. You can definitely nest a try catch block within another try and catch block. It's pretty much like how you do if then else. You can nest it. You can nest one if statement inside another if statement. The same idea. I have another exercise at the end to ask you, what if we don't nest the try and catch block? What's going to happen, right? That's kind of justify what we're doing. For now, take it for granted. So now we are saying, overall, we have an outer try block for which we simply do increments 3 times. And then after that, we try to do another try. Okay? And this is when we do the this is when we do the 4th, the last increments. Okay? For the first 3 increments, we do not expect the value too large exception to be thrown. For the 4th one, the opposite, we do expect it to be thrown. Okay? So now we say that if we're expecting this one to be thrown, but if it was not thrown, we say error. Okay? That's exactly what line number 10 does. We have seen this already. And then we say that if it was thrown from line number 9, the increment, the exception value too large exception, in line number 13 in the catch block, we say, well, it's success because it's there. Now, try to see this. Okay? I want you to look at line number 6. Line number 6 over here, if any one of the increment method here actually throws the value too large exception unexpectedly, we have to catch them somehow, of course. So that's why you see another outer catch block. In this outer catch block over here, we say if this outer catch block catches the value too large exception, that means it must be from one of the first 3 increments. In that case, we say value too large exception thrown unexpectedly. When you study this example, what you want to ask yourself and convince is this. Why? First of all, in the inner catch, why do we consider receiving a value too large exception as success? Number 2, in the outer catch block, why do we consider receiving a value too large exception as an error? So that's the question. Okay? I hope you're not completely lost yet, right? You know, logic is very similar. Okay? Now let's do some example. Okay? Basically, we're going to see exactly how we can create different kinds of errors and also try the normal case as well. Okay? We're going to try to trace 3 cases. So now I'm not going to bother with Eclipse. I've shown you how you can do it. So let's now go directly to iPad. Okay? Basically, that's the code I have just explained. I want you to focus on line number 10, line number 13, and line number 17. Okay? Line number 17 comes from any value too large exception from the CETA increments in line number 6. Line number 13 comes from line number 9, CETA increments. Okay? So now, let's see. Oh, one more thing to say, okay? In case you're a little bit concerned, this particular pair of try and catch block, they go together, right? On the other hand, this particular try and catch, they go together, right? Okay, good. So that will make sense. So now let's try this. first of all, let's try the correct implementation. Let's always try the correct one and see what happens. So now the correct implementation is when so we talk about increment now, not decrements. If the value has reached the maximum value, in that case, we should throw the value too large exception. So that's correct. Let's see what's going to happen. So now, first of all, we create a new counter over here. And then in line number 4, we try to print out the counter value. In this case, that should be 0. Okay? And then we enter the outer try block. So let's say we do line number 6. Basically, because this is correct. So now, C dot value over here is simply 0. 0 equals 3. The maximum value is false. So we don't throw the exception. That's good. So we increment from 0 to 1. And then when we try to increment C dot increment the second time, so now the value will be 1. So now 1 equals 3 will be also false. So we don't really throw the exception. And similarly, increment to 2. Yeah, so from 0 to 1, 1 to 2. And then when we try to increment the final time, we'll go from 2 to 3, right? So far, no exception has been thrown. So now, are we continuing to which line after line number 7? In this case, no exception has been thrown, right? 7, agree? Yeah, good. I just want to reaffirm, right? Yeah. You know, sometimes I ask questions I can answer myself, but sometimes I do expect you to, give me a little bit, response. That'll be nice. Number 7, good. So now this one is the current value over here will just be 3. Okay? So now that means we're now entering the inner catch block. So now here comes the critical thing. When we call this method here, C dot value is simply 3. Okay? So now what's going to happen is, let me just clear this a little bit so you don't get too much noise over here. Because currently, C dot value is simply 3. So we got 3 here, equals maximum 3. So now we are going to throw the exception. That means we're going to go to which line? 12? I agree, because the flow will be disrupted. After this, we're going to go to line number 12, and this is thrown as expected, so we're going to execute this line and say success. Okay, that's it. Normal case. Okay, so far we covered the first case where the implementation is simply just correct. Let me highlight it. So we're going to print out this particular success message. That's the first one. Okay, and now for the wrong implementation, I'm just going to give you one example. The second one is going to be an exercise for you. Okay, let's do the first wrong implementation. Let's go over that. Okay? Again, there's a link over here. If you click on the link, it will bring you to the corresponding JUnits. You can look at that when you study the slides. Okay, what we just looked at was this particular one. If you try to play with the code, it will tell you success, value too large, exception thrown. Let's now go to this case over here. I put it as an exercise. I'll do the first one together with you. Okay. So now I want you to give an incorrect method increments. Okay, such that I want to have, basically, I'll explain to you what this means. You can read it more carefully when you study it. I want to make the implementation wrong so that C.increments in line number 6 is going to throw the value too large exception unexpectedly. If it was the case, that means from line number 6, we're going to skip the rest, go to line number 16 directly, and then say error. Any suggestion? Let me switch to iPad over here. So now we talk about second case, right? So now currently this is the correct implementation. Anyone to suggest to everybody, oh, sorry, that should be highlighted. Currently this is correct. Is it possible to modify this to be something else so that it's wrong? Yes. However, okay, I see what you mean. What you're suggesting is, I tell you why it will be wrong. It will be wrong to create a wrong implementation, right? For this case, why is that wrong? What you're suggesting is, if I simply say, if you simply say value less than or equal to the max. Remember, less than or equal to simply means less than or equal to. So you still got this equal over here. That's a problem. So you will still throw that exception. So you will still actually avoid that, right? Oh, if you, oh, I'm thinking wrongly. I beg your pardon. Yes, I think less than or equal to is fine. So that means when you think about it carefully, when you answer. Okay, let's try yours. Why don't we? So what you're suggesting was, if I simply say, rather than this, I'm going to say less than or equal to. Let's try, okay? So now that means, okay, after initial ones, okay, we're simply going to see the increments. At this point over here, see the value is simply just 0 from the initial setup. So now we're getting 0 less than or equal to maximum value, which is 3. That's true. So that means, yes, we're going to throw this particular exception. So now, tell me, if the value too large exception was thrown right away, which line should we go? Should we go to line 12 or should we go to line 16? That's an important question. Why 16? 16 is correct, but why 16? That's exactly right. So you got to be careful because in this case, we got 2 pairs of try and catch. You want to know which one to go. So this particular try, go with this particular catch. Okay? So now if this is thrown, you'll skip all the rest. Go to catch and then say error, thrown unexpectedly. Okay, very good. Yeah. Okay, guys, any question? That could be a possible question I can ask you. Yes?
What happens if we add in the line 6 another method C.method?
Aha, very good question. Very nice question.
That will still go to line 16.
That's a very good question. What the question was, it will be answered somehow in a different way, but I will just address that. Your question was, let's say we do expect see the increment, see the increment, see the increment. We don't expect anything to happen from here, right? What you're asking is, what if we say see the increment the 4th time over here as opposed to in a different try and catch block? The answer is your tester becomes bad. Because, I tell you why, you want to try to explain why it is bad? You can always contradict yourself, that's fine. You can try to explain why it would be bad, let's say.
Well, it would be bad because it would never, if the initial value is 0, it would never reach lines 8 through 15 ever.
True, but there's a more fundamental reason. Okay, let me try to see if you can get this point. So now, let's say what your colleague was suggesting was, let's say we don't really put it here, let's say. Okay? We simply put a 4th one over here. Okay? So now, question for you. It's very easy to, let's think a little bit backwards. We know that all these 4 increments all belong to the same try block. Okay? 1, 2, 3, 4. They all belong to try over here, which means if we ever get to this particular line 16 and catch the exception, value too large exception, are we able to tell which one it is? We only know that if we ever got an exception over here, all we know is it comes from this particular try block. That's all we know. But that try block contains 1, 2, 3, 4. It could be this, could be that, could be that, in which case that's fine. In which case, of course, that's unexpected. It could be that as well, in which case that's, yeah, the other outcome, right? So it's a bad tester if you do that, but that's good. So guys, I think when you review the lecture, I would say, look at that to ask yourself why putting the 4th, the last see the increments over there is a bad idea. Okay, I like that question. You will see something very similar in just a moment. Basically, the exercise I want to ask you to also try on is, rather than having 2 nested try and catch block, what if I don't have nested try and catch block? I will show you. Okay, that's another thing to think about. Question? Yes.
The first option that we keep less than or equal.
Yes.
So what's wrong?
What's wrong with that? Sure. You were asking basically this. Let me clean this just a little bit so we can have a fresh discussion. You're basically asking over here, what your colleague suggested was, we know that having equals is correct, first of all, right? But now, if we modify that to be less than or equal to, okay, what's the consequence of that? The consequence of that is, when you reach the first C dot increments, first of all, right? C dot value at that point is simply 0, agree? In that case, That means you're checking this particular condition. See, the value is simply 0. And then the maximum value, we set it to be 3. 0 less than or equal to 3 will give you true. That means in the first C dot increment, you are already throwing this exception. That's unexpected. That's wrong. Because when you are trying to increment all the way to the maximum, all those first 3 increments are just normal. They're fine. However, it's only the fourth one originally that we're trying to do that's wrong, right? Because you cannot, once you reach the maximum, you should not be able to go further, right? Yeah, you want to really distinguish between, so that's the interesting thing about this second example is we got 2 kinds of increments, right? Either the first 3 or the last one. They serve different purposes, okay? Questions? Good. Yes?
So, just as if you were to say get rid of the nested try and catch block,
I'm going to do that, yes, if that's what you're asking. Mm-hmm.
and instead, if you just in your increment block just added, like only for the question space, added its current line.
Added what, sorry?
For it to print its current value in the condition.
Yeah, basically you're saying that maybe add a little bit more print statements for the increments. You're just suggesting another way to write it. I would say I wouldn't go that far. So you can definitely write tester the way you like, but let's focus on this particular logic. I'm just saying, first of all, having a nested try and catch is necessary for this, number 1, right? Number 2, you cannot put the first 3 increments and the last increment in the same try and catch block. That's the main message. How you actually write around with that, we can discuss offline. Otherwise, we might confuse everybody else. Yeah. Okay. That's any questions here? Okay, we're getting to something, really require your thinking, right? That's exactly why you need this course, right? Okay, so that's the first exercise. So now, a second exercise for you to do, okay? I will give that as an exercise for you. So now, let's say this. Let's say we want to modify the implementation of increments to be wrong so that the first 3 increments will not throw the value too large exception. However, in the fourth one, in line number 9, you will not throw that either. Okay, that's wrong, right? Basically, we talk about 2 kinds of wrong situation. The first wrong situation is you throw the value too large exception too early. And the second exercise I want you to do by yourself is you never throw it, basically. That's too bad. That's too late. Okay? So that's kind of the exercise I want you to do. So when you read the slides, you're going to see that you want to have basically the error message from line number 13, which is going to be, sorry, not 13, beg your pardon. It should be line number 10. What the error message I want is from line number 10. Value too large exception not thrown. It was expected to be thrown from the 4th increment, but it was not. Think about how you can do it. Verify by yourself. It will be something similar to what you had to do for the previous one, right? Okay. Any questions so far? So far we have seen 3 console testers so far, right? And each one of them illustrate different points. I hope you at least get have some reasonable understanding. Okay. Okay. After this, let's see what's the next. Okay. So now, comes the discussion I promised. Okay. Let's say, why do we need try and catch to be nested? Let's say we don't have try and catch being nested. What's going to happen? Okay. So now we're going to focus on the tester itself to criticize. Okay. I'm going to go over very quickly because I do have hints at the bottom for you to think about. Let's say we still have creating the counter value, creating the counter, and then query its value should be 0. So now the first try and catch block, we simply do the first 3 increments, right? No nested, okay? And then after the first 3 increments, we do another non-nested. It's not nested, right? It's simply another try and catch block. Do the 4th one. Okay, so here I'm simply saying, for the first 3, because I don't expect any exception to be thrown, if in case I get to line number 9, that should be an error because it was thrown unexpectedly. On the other hand, starting from line number 12, I'm doing the 4th one. It's the opposite case because I do expect the exception to be thrown. That means if I can continue from line number 13 to 14, that means the exception was not thrown. In that case, that should be an error. However, this tester over here, without nesting the try and catch, is not correct. It's not appropriate. How about that? I do accept any answer quickly if you want to speak up your mind before I tell you, give you a little bit hints. Please.
I think the first the second is
Tell me which line you're thinking about. Line number 13. So basically, of course, depends on how you implement increments. It could be that maybe, let's say, in line number 13, C dot increment is simply 3, let's say. Yeah, it could be, right? Mm-hmm. Let's more think about, how about this? Yeah, basically more thinking about the condition of throwing the exception. That's something we're thinking about. Yes?
Yeah, if you do get an exception in the first try catch block, you might not want to continue doing the second one because that exception, the second block might not make sense then.
That's exactly right. Okay, if you don't mind, let me repeat. What your colleague just said is 100% correct. Let's say this. In line number 10, let's say we do get to line number 10. If we get to line number 10, that means one of the first increments from line number 6 has thrown the value too large exception unexpectedly. At that point, should we continue with the test, or should we just say, no, it should be an error? We should say, not continue, right? Because we already seen an error from the implementation. However, the current setup goes like this. Let me see if I do have that on my iPad. Let me see that. I do have it, okay? Okay, let me sketch the idea for you. Okay, basically the hint is exactly what you just mentioned, okay? So now let's say this. Let's say, what if one of these throws value too large exception unexpectedly? In that case, we're going to disrupt the flow and go to the corresponding catch block and print out the error. So far, so good. Okay? However, after line number 10, and we finish that corresponding catch block, what would be the next line? Well, actually, yeah, 12, because we simply exit from that particular catch block, and then there's just another one, not nested, just another one to try. So after that, we're actually going to go for another one. The fact that we have to continue is inappropriate. Inappropriate because once an error is discovered, sorry about my writing, once an error is discovered, tester should report and terminate right away. Report and terminates right away. Okay, that's the main idea. Okay, think about this particular exercise. You'll see a little bit more detailed hints on your slides, but that's a very quick walkthrough. So that's the main issue. Okay, so do expect questions similar to this. I might just give you a console tester over there. It compiles, but you have to think more deeply about what's the issue over here. Think more about if something that goes wrong, is the tester going to report the error and terminate immediately, rather than going further with more execution of the method. That's the main idea over here. Okay? Any questions before I move on? Okay? All right. After this, let's see, I believe that's all the example about console tester. Okay? And then hopefully we can move on to JUnits. Okay, that's just one more. So this one here, I'll point out exactly what this one is about. I'm just trying to show you another, a little bit more convenient tester, right? Basically, we simply use a while loop. Basically, let the user keep entering input, and then they can test the counter. I'll run on Eclipse just to show you, so you get an idea. You can study that code, okay, just using a while loop. It's a nice case study. So what I will do is, first of all, I'll stop the debugger. I think stopped, so go back to Java. So what you need to do is run the console tester 3, which has a while loop. I'll just show you exactly how that works from the user's point of view. Basically, it will prompt you for different commands. You can either say increments, decrements, or value. If I say val, it tells me currently the value for the counter is 0. And then I can say, for example, decrements, you tell me value too small, right? It didn't crash on me because somehow the program internally has a try and catch block. I'll leave that to you to study. Okay? Or I can say increments, the value should be 1. Increment another time, the value should be 2. Increment one more time, the value should be 3. Now, if I say increments again, value too big. Okay? The advantage of this tester here is a single tester. You can run so many different test cases with that. As opposed to previously, console test 1 consider only one scenario. Console test 2 consider just another scenario. But now we can do everything together. However, in order to connect us to the JUnits, even for console test 3 that's done iteratively over here, it is still a fundamental drawback. Let's say this. Every time you make a small change to your program, you want to test your code again, you have to run this and type from keyboard manually. Inspect by your eyes to see if outputs are actually correct. That's too inefficient. Let's say for a complicated application, way more complicated than your labs, you have maybe 100 different test inputs to try. Do you want to type 100 times like this every time when you make a small change? In a realistic setup, you may have to modify your code every 1 hour or even shorter than that. In that case, you don't want to repeat this manual testing process every time. So now this is exactly the motivation for having a framework like JUnits. The console tester, either iteratively or separate tester, they work on a very small scale. So they're not realistic. What we really want to have is a framework called JUnits. You have already been a user of JUnits, but now I'm trying to explain to you what's the underlying justification for using it as opposed to console tester. Okay? So now we can move on to JUnits. And when you study that particular code, I'll just tell you. So you can focus on what I highlight, right? You can look at the counter and call increment, decrement, and get value. Okay? You can look at that. That one is not difficult. It's very similar to the circle calculator, the iterative version. Very similar. Okay? I'll leave that to you. I don't want to waste your time over here. Okay? So now, let's now talk about limitations, as exactly what I said. So far, we test about 2 cases. We test about when the value is too small, already reaches the minimum, we try to decrements. And when the value reaches the maximum, we try to increments. 2 cases. Do you think the number of test cases are enough? Intuitively. Yes? No? Any idea? Let me put it another way. Do you think in order to test if the code is actually correct, do you think we need more test cases? We definitely need it. And the next question is, how many more do we need? That's the question. Okay? For this particular example, it's quite easy to maybe show you a quick strategy about figuring out the number of test cases. Okay? So now, let me show you a table very quickly. Okay? So this one tells me the only allowable values for counter, 0, 1, 2, 3, and no more. In each value, we have the option to call either of the mutators. You can either call increments or decrement for each of the cases. Of course, when you, let's say in the case the counter value is 1, you can call that increments and get 2. You can call decrements and get down to 0, right? Also in the boundary cases, you might also get exceptions. Okay? That's kind of the one way to figure out the test cases. Okay? Let me show you a very quick diagram. Okay? So this is basically, well, in this kind of small scale, it's okay. We can use this diagram, but I just want to give you an idea. When you are trying to test your code, you need to have certain strategy about being systematic. For those of you who are taking 2001, maybe you have seen something like this already, right? DFA, maybe? Okay. So now, basically, how many circles you draw depends on how many possible values are there for the value we are trying to test. In this case, it's between 0 and 3. That's why you see 0, 1, 2, and 3. Okay? In each value over there, we call states. We want to try all the possible methods. In this case, it can be either increments or decrements, right? Basically, what you got to do is, in value 0, we can try increments, in which case we'll go to value 1. Value 1, we can try increments again, in which case we go to 2. Try increments again, we go to 3. Now, if we try increments again, what we will get is exception, right? Okay, value too large, exception. So we talk about 1, 2, 3, 4. 4 test cases already you have to do. Okay, let's go the other way. Once you are in the maximum over here, you may go for decrements. You might go for decrements again, and you might go for decrements again, right? And now, I may also call decrements, but that would be the boundary case in which from 0 to -1, that should give me a value too small exception. So in total, we have exactly 8. Okay, so now in total, if you count 1, 2, sorry, I'm a highlighter. 1, 2, 3, 4, 5, 6, 7, 8 to be complete for this particular example. It's not too big, just 8, simply because the allowable value for the counter is only 8. In some other cases, it will be much more complicated, but just want to give you an idea how you can come up with some strategy for testing your objects. Okay, that should be quite straightforward, right? I hope. Okay, okay, let's go on. Okay, total 8 test cases. Okay, again, the problem about having console test is inconvenient. Every time you got to do it manually and check it with your eyes. You don't want to do that. You basically want a very automatic way to say, if everything is all right, it's going to give me a green bar, which you have seen before you submit your lab. Or if anything that's wrong, give me a red bar, right? That's kind of the idea for JUnits. Okay, so why JUnits? That's something we want to talk about. Okay, we want to automate. What I mean by automate is, once you add in a particular test case, you don't have to run it manually again later on. You can just always run it as part of the package. Okay. 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 And then we also talk about success and failure. Let's learn from the example. I'll get there. Okay. So now basically we're gonna do the logic that we're gonna code in the JUnits will be exactly the same as before. Okay. So now all we need to learn is about a syntax for JUnits. And for your written test 1, I wouldn't expect you to write any JUnit test. That's okay. However, you're expected to read it. Okay? For your lab test programming test, you're also supposed to read it, but possibly write some test cases yourself as well. Okay? But that's going to be more time for you. Okay? Let's try. So now, how do you create JUnit test? Okay, I'm going to skip this particular slide because that's in the slide. I'll just show you very quickly how I can do that in JUnits, and then I'll go to this slide directly. Okay, so now in the JUnits, in Eclipse. So now let me go to, let's say this, we have got our counter, right? That's our code. That's our implementation. How can I create a test for that, JUnits? Let's say we create another package called tests. That's going to store all the JUnit test classes. Right click on that, and then you would say new, and then I can say JUnit test case, okay? And then choose version 4, okay? We're using version 4. And then I can say, for example, test counter. And then I will say finish. First time, it's going to prompt you to say, for your particular project, JUnit is not in the library, add it. Okay, just the first time. So I'm going to say, add it to my path, say okay, and then done. Okay? Now, whenever you create a new test class, this is the only method that will be generated by default. Let's analyze this method a little bit, okay? Before I analyze it, what if we try to run it? Have you ever tried? If not, let's try together. If I say run as JUnit test, would you expect red or green? Red. Tell you what, it's very easy because by default, it simply says fail. Intentionally, it wants you to fail this particular test. I'll show you one more thing. What would be the easiest way to pass this test? Why don't we get rid of the fail? Oh, sorry. Okay, it's now been commented out, has no effects. We run the test. Yay, green. I tell you what I just illustrated. Having a green bar for your project of a JUnit test, in theory, means nothing because it depends on the quality of your test. This test over here, although it's passed, has no quality. Okay? That's a lesson for you to learn. Every time your colleague tell you, oh, you know what? I finished this big library. All my JUnit tests passed. You should be reserved and go to look at their JUnit test. Maybe they got something like this, repeated 100 times. That's meaningless, right? Okay, so now I want to give you the principle about what does it really mean when a test pass or fail. Easier to talk about pass, very easy. Whenever a test case in JUnit pass, that simply means there is no assertion failure. Number one, I'll talk about what assertion is in just a moment. If no assertion failure, and also no uncaught exception, then it's expected it will be considered as a pass. Okay. When you look at the slides, okay, I'll show you. I'll show you the iPad here. So now it would be a failure if assertion failure. Assertion you have seen many already, mainly the assertEquals over here, right, in your lab. Okay, assertEquals simply means I'm expecting some value to be happening, and then I'm going to try out my code to see if the produced value will be matched. If they match, assertion success. If they don't match, assertion failure. Okay, easy. And then another common source of failing your test is maybe you have null pointer exception. Maybe you have array index out of bound exception. Okay? If any of these happen, that means it's a failure for the test. Otherwise, it will be a success if nothing unexpected happened. But now, if you look at the default, this one intentionally failed. It's an assertion failure. On the other hand, if I put this away, it simply does nothing. So that means nothing will fail. So that means it's a pass. Okay? Remember the principle over there. Under what circumstances can your test fail? That's most important. Okay, and then we're going to see a little bit more example over here. Okay. Okay, that's exactly what I said. Okay, so now when you run all the test cases, let's say you got 100 different test methods to run, and then it will only be green if all the tests pass, which means nothing unexpected as assertion or exception happened, nothing unexpected. If there's at least one that happened to be unexpected, you will get a red bar. Okay, easy. Okay, so that's exactly what I just did, right? I commented out, so I don't need to repeat. So now what we need to do is to think about the syntax for JUnits. So these are the common assertion. I'll give you an example in the next two slides, don't worry. One thing is about assert if an object is null or not, right? Also to assert whether two integers are equal, okay? And when you are trying to compare two floating point numbers, if you simply say, I'm expecting 3.1456 to be expected, and I'm trying to call my method to return that value. Usually when you compare double value, you don't really just compare them directly. You have to give something we call epsilon to allow certain tolerance. I will give you one example. It's very easy to understand. And also, you can also assert on the array. We don't really use this a lot, but it's there. Okay, you can try that too. And also assert true. Okay, assert some Boolean expression. If it is true, pass. Otherwise, fail. Also assert, also fail intentionally. Okay, so now let's run through examples very quickly. Okay, let's give it a try. Let's say we have a point class. We simply got points constructor. Let's say specifically the x and y are simply integer, and the constructor get x, get y. Very simple. So now, do they pass or fail? Very straightforward. Let's give it a try. Let's say we declare a point P without initializing it. What will be the default value? At her 0, that's not good. Null, right? Be careful. Okay, if I ask you that, you want to get it marked, right? So now assert null. Should that be a pass or fail? I'm basically asserting at this point, should P be storing null or some object address? Because P is uninitialized, so that should be storing null. So that means it should be a pass. Guys, does it make sense? Basically, you just pass an object variable over there and then ask whether it's storing null at the moment. On the other hand, I'll give you more example. If I say assert true, I say P equals null. Should it be true or false? True. So pass. Okay? If I say P, this one is a bit tricky, right? It's like a double negation, isn't it? Okay, first of all, let's be careful. P not equal to null. Should that be true or false? False, right? P is actually null. Null not equal to null will just give you false. And then false is exactly what we are asserting for, false. Right? Pass. Oh, sorry. Did I assert, you know what? Okay, I just got a wrong annotation here. I beg your pardon. I'm going to fix it. Don't worry. Yeah. That's a problem when you try to make slides the last night. So now, First of all, P is null. Agree? Null not equal to null would be false. And false is exactly what we are asserting for. That should be a pass. That's typo. Okay? I'm emphasizing, if you're watching video, this is typo. Okay? Okay, that should be a check. All right? Sorry about that. How about this? Assert equals. Basically, the number 3 there is saying I'm expecting 3 to be returned. And p.x, I'm checking my implementation. Would that be pass or fail? Well, you can see, well, basically, well, you know, this one is interesting. Pass or fail was something else. I'll give you a little bit hints. In order to evaluate the second p.getX, you have to somehow get to wherever p is pointing to in the memory, and then call getX. Yeah, because remember p is null at this point, right? When you are trying to evaluate p.getX, you already fail. Null pointer exception. Okay, be careful. Okay, this one is a little bit tricky. Okay. Okay, that should be null pointer exception, but it's also a fail because it's unexpected. Okay, now let's do a little bit more. Let's say p is assigned to new point 34. Okay. Now let's do something very similar again, please. Assert now p, pass or fail? Fail, right? Because p is now storing the address of some point object, so it should be fail. Good. Assert true, p equals null. Okay, I help you with that. P is basically not null. Equals null would be false. False is not what we are asserting for, so that should be fail. On the other hand, now how about this? P is not null. Something that's not null, not equal to null.
True.
Yeah, that's true, right? So this should be fail. True is exactly the opposite of what we are asserting for, which is false, right? So now it should be fail. I'm being consistent. I made the opposite typo. I'm going to change that. Again, if you're watching the recording, it should be a fail. Okay? Now, what about this guy here? Okay, no, by the way, you shouldn't say true or false. You should say pass or fail, right? Okay? Pass. Very good. You guys are smart. I'm glad. Okay, final one. So now this one shows you more about assert true because it's only expecting a Boolean expression. So you can use conjunction, disjunction, negation, whatever you like. How about this guy here? What? Pass, right? Very good. I like that. Pass. So now p.getX will be 3 equal to 3. That's just correct, right? It'll just be pass. Very good. So now you got the idea. At least you're able to read it. Okay, let's do one more. I want to show you how the assert equals with 3 parameters could be useful. Let's say this. We have circle radius, and then also we just set the radius, and calculate the area is going to return, again, a typo. Sorry about that. The return type for get area should be a double. Okay, it should be a double. Okay, beg your pardon, again. So now, how do we test c.getArea? It's returning a double value, not integer value. Okay? So let me switch to iPad and tell you the story over here quickly. Okay, so now basically what you will have is this. Let's say this. This is how we test it. So you create a circle C and then 3.4, that's the radius. So now when we say c.getArea is going to calculate 3.4 multiply 3.4 multiply 3.14. If you calculate it on your calculator, this is the value exactly, 36.2984. Take it for granted. Okay? So now, if you simply say assert, again, what's wrong with me? Assert equals. If I simply say assert equals over here, however, I only say 36.2984, comma, and then I simply say c.getArea. This will compile, but Eclipse will give you warning. Don't do this. That means you're comparing 2 double values together right away. That's not good. Because to make the long story short, what we are thinking about mathematically is base 10 numbers. Computer are binary numbers. It's not possible to represent your base 10 numbers perfectly in the base 2. That's a short description. Anyway, anytime you want to compare 2 values of double, do not try to assert equals directly. You should allow certain tolerance. And what does this really mean? That means whatever I put over here, 36.2984 minus 0.01. That's the minimum I can get into. It can be a little bit, epsilon, less than or equal to c dot get area, okay, and then less than or equal to 36.2984 plus 0.01. So we do allow some tolerance over here. Okay, that's just something you want to pay attention to. You don't have to write this kind of assert equals in your lab test. Don't have to worry. But when you see that in the lab test, you should know what it is doing. You're just asserting some tolerance on the double number. Okay, if you go back to the slides, what you will see is our promise. I'll fix all the typos. Okay, basically that's exactly what we're asserting here. Right, pass or fail. Right. Good. Okay, that's just more information about other assert. But the ones I just gave you examples about, that's all you need to do. Okay. So now what we need to do, I got about 10 minutes. Okay, let's see how much we can do. I wouldn't rush. What I want to do now is, let's see how we can apply the JUnit syntax into something we have done already. But it's now, rather than console tester, let's now do JUnit test. It's very easy to follow. Okay, let's do one together in a little bit more detail. The first test we're going to run, we are saying that we are not expecting exception to be occur. We are not expecting. Okay, let's see how the code should be written. Let's see this. In the normal case, we'll simply say initialize a counter, and then assert equals. We want to make sure c.getValue, which is actual value, is as expected, which is minimum. Okay. So far so good. That's assert equals. Easy. So now c.increments, we're going to try that. Okay. At this point, do we expect to get any assertion? Oh, sorry. At line number 6, do we expect to get any exception when we want to increment from 0 to 1? We do not, right? That means if we ever get to the catch block, that means error. What we did previously was simply to say print out error message, but now we simply say fail. Easy translation if you want to think this way. Whenever we say system.out.print line, error something, replace that with fail in JUnits. That's one way to think about. Okay? So now what about a failure case? Let's say if we try to, okay, again, we initialize a counter, do the assert equals. Now, when we do increment, let's say it does not, let's say it does not throw value, oh, sorry, let me say it again. Not does not. Let's say in this case, it throws value too big, exception, unexpectedly. Okay, in this case, did I say something about the opposite? Let me just try to do it again, okay? I don't want to confuse you in any way, okay? Let me start it again. I just noticed that, okay? If we try to do c.increments, let's say c.increments over here, okay, is implemented correctly, in which case it does not throw value too big, exception. That's expected. So now that means we can just go to the next line, in which case make sure the value has been incremented to 1. That's normal case. Sorry about that. Okay. Now, incorrect case. Initialize the counter, go for c.increment. So now let's say it's a wrong implementation. So let's say it throws value too big, exception, unexpectedly. In that case, we're simply just going to break the flow, disrupt the flow, go to catch, and in which case we're going to say fail. Right? These are the two cases. If you try to study this slide, I would suggest put this slide here side by side with the console tester, right, to see how the two flows are different. Yes?
What if the assert equals isn't true?
Oh, assert equals, you mean, okay. Let's say this. Assert equals, over here, you can see what we're doing is, after we have incremented the counter value, because remember, after the initial one, it's simply 0. Agree? Okay. So now let's say if increments has been implemented correctly. Number one, it's not going to throw the exception. Number 2 is going to increment from 0 to 1. That is why we simply have 1 here. Which means at that point we can now assert to make sure, since there's no exception thrown, so now let's make sure the value has been incremented from 0 to 1. That's why I put 1 here. Okay, make sense? Good. Okay, let's do another one. Okay, this one here, let's see. This one corresponds to console tester 1. Okay, so when you try to review your slides, okay, I'll show you what you should do. When you review your slides, basically when you review this guy here, it's called test decrements from minimum value. Okay, when you try to do that, you simply just have to click on the link and they will link you back. Okay. Oh, one more thing to emphasize. If you ever have to write your JUnit test, notice line number 1. You always have to put at test. That's required if you ever have to write it yourself. Okay. So now let's see the logic. Okay. So I just put the console tester over here just for your information. Okay. Let's try this. I'm going to execute in parallel. Let's see if that works. Let's say, okay, we try to initialize the counter in both cases, and then over here in the console tester, we simply print out the value and make sure it is 0. In the case of JUnits, we make sure it is now the minimum value. You can see very similar, but now it's simply an assertion rather than checking by your eyes in the console tester. And now we got to try and catch. Let's say we go to c.decrements over here and c.decrements over here. Now, let's say we have correct implementation. Correct. Correct implementation simply means the value to small exception is thrown as expected. Because we are trying to decrement when it is 0. Now, in this case, should we go to the next line or go to catch? Catch. And then it simply does nothing. That's basically the trick I did to remove the fail, remember? When you simply do nothing, that means nothing is going to violate the assertion, nothing is going to throw any exception, so the test will be considered as a success. Okay. On the other hand, let's see what's going to happen in the console tester. That's in the console tester, again, if the value to small exception thrown as expected, in that case, we'll simply go to the catch block and we'll simply say success. Right? In the case of console tester, you print out success to the console. In the case of JUnits, you don't do anything. That will make the test success. Just pass. That's the normal case. Let's try another case quickly. So now I go to, let's say, I'm going to use red. I initialize the objects, and now I assert equals. Let's say these are okay. Okay. I go to try block. So now let's go to here. Look at line number 6. In line number 6, let's say now we think about if the implementation is incorrect. Incorrect. Let's say for decrements over here is value to small exception not thrown. Okay, it's not thrown. In that case, what should we do? Next line. Fail. Okay, you see the logic here? Completely the same. Similarly, if we try to do decrements over here, and then let's say value to small exception is not thrown, so that means it's wrong implementation. In that case, we go to the next line, error. Whereas we say error in the console tester, now we say fail. Okay. So now let me tell you. Okay, I can let you leave earlier today. Give me 30 seconds to tell you what you should do. Okay, between now and the review session. So we basically finish everything you should know. So now you should be able to follow another test, which is similar to what we said for another console tester, the same. Okay, I'll leave you study for that. Ask me a question later. Okay, I think about this particular exercise as well. Okay, study all the way to the end of the lecture and let me know if you got questions. So this will be all the coverage for lab test written.